Hello, my dear friends, good evening. I welcome you all to my physics channel Ankur Academy. Right, so friends, for class 12th, today I have taken the topic of angular deviation through a prism. This topic is very important and it belongs to the chapter called as ray optics in class 12th. Friends, look at the figure. This is the ray of light going to fall on the prism like this. But at this point, there is refraction. You have understood, right? Refraction. The phenomena of change in the path of light when it passes from one medium to the next medium is called as refraction. But after traveling like this and at this point again, the direction of light changes and it goes into the air. So here also the second time refraction is taking place. If we are going to have the direction of incident light like this u and the refracted light, final emerging light like this, if both of them are going to extend in the reverse direction, then they have the meeting point at this point. So at the meeting point we are going to have certain amount of angle. This angle is called as angular deviation through the prism. This angle is called as angular deviation through the prism. So today's topic is on the angular deviation through the prism and this is our target which we are going to derive. Okay, now we are going for the derivation of this topic. Right. Now the topic definition. What is the definition? The change in the direction of incidence light on the prism So friends, let's start. The first point is the definition. Question arises, how to define the angular deviation? What should be the definition of angular deviation? So I just want to say the angle formed between the direction of incident ray of light and the emergent ray of light through the prism is called as angular deviation. So you have understood, right, what is the meaning of angular deviation, just which we were discussing the concept in the last page. Again I am going to the last page over here. See the last page. This is the direction of incoming light and this is the emerging light. Both directions have certain angle between them. This angle is called as angular deviation through the prism. Right. So I hope the figure is clear to you, and now we are going for the derivation. The definition point is clear. Now the next heading is the derivation. So friends, just we are moving to the topic of derivation. How to derive? What should be the main motive of derivation? So friends, let me draw the figure again. This is the prism, right? And let this be the point of incidence and this be the point of refraction. Okay friends, now the light is falling like this, moving into the prism. After that it emerges like this. This point is also clear. Suppose this is the direction extended u and this is the direction extended u. Let's draw the normal also. This is the normal and at this point again the normal is drawn like this. Right? So this is the figure. Let the prism be called as A, B and C. And this point, let it be L. This is O and this point is M. Now the concept is perfect. Okay friends. So let the angle, this angle is called as angle of incidence. This concept is also right. And this is called as I1 incidence angle, and this is called as I2. Take. This is called as R1 angle, and this is called as R2 angle. Everything is perfect, right? So friends, we already know incidence angle and refraction angle at the point L on the face AB, incidence angle and refraction angle at the point M on the face AC. Take. This thing is called as deviation angle. This thing is called as deviation angle, right? I hope the figure is clear to you. Now we are going for the derivation purpose of the topic. Okay friends. Now the derivation. Let's have a close look at the figure. Friends, this is the incidence angle and this is the refraction angle. So what should be the remaining angle? If I am not making mistake, so we have the concept of vertically opposite angles. This angle is I1. So obviously this angle should also be I1. The first angle is R1. So friends, how much is the remaining angle? This should also be written as I1 minus R1. I am saying I1 minus R1 and repeat the concept. If this angle is I2, the vertically opposite angle will also be I2. The first angle is R2. The remaining angle, this remaining angle will be called as what? I2 minus R2. I2 minus R2. Okay? Right. Let this point be taken as P. So let me draw the figure again over here, U. Again the figure is drawn like this, U. Friends, look at the figure. The triangle LPM. LPM. I am again drawing this figure. From here LPM. Again it is drawn over here, LPM. So friends, this angle is I1 minus R1, right? And what about this angle? This is I2 minus R2. And what about this angle? This is deviation angle, right? So what is the concept? What is the point? Concept is like this, key external angle delta, exterior angle, is related to two opposite interior angles. So how should we get? What is the relation between del and these two angles? Del and these two angles. We very well know in junior classes we have studied the concept. Any exterior angle of the triangle is just the sum of two interior angles. Two interior angles. So we have the concept by exterior angle property. By exterior angle property. By exterior angle property. What is the exterior angle property? It just says the external angle must be equal to the sum of two internal angles of the triangle. The two internal angles are what? I1 minus R1 and the next angle is I2 minus R2. Right friends? If we open the bracket and on simplifying, we get the result as I1 plus I2, the first minus sign, R1 plus R2, U. And let this be called as equation number 1. This is called as equation number 1. Right friends? After this, what is the logic? We will go for the derivation of R1 plus R2. Then we will go for the derivation of I1 plus I2. Next we will substitute the result for R1 plus R2 and then I1 plus I2. And after simplification, we will get the final result for del. That is the angle of deviation. Okay friends, now the next target is to derive the result for R1 plus R2. Okay. Right friends, the first target, what we have to find? I am going to find first of all, my target is to find R1 plus R2. You have heard right. I want to find R1 plus R2. The question arises how to get R1 plus R2. Very simple. Look at the figure. Look at the figure. Where is the figure? Why this is the figure. PLM. Here also we have the figure like this. PLM ALOM like this. So first of all we have to look at the quadrilateral ALOMA. Friends, look seriously. ALOMA. So what should be there? We have to use the angle sum property in quadrilateral ALOMA. So let us write down. Using, what I have to say, using angle sum property. Using angle sum property. Where we have to use angle sum property? In quadrilateral. Where we are going to use? In quadrilateral. And what is the name of the quadrilateral? The quadrilateral is called as AL. Quadrilateral is ALOMA. Right. So let's start, friends. Quadrilateral ALOMA. This thing is clear. Now the point. The first angle. The first angle is A. So let's write down the first angle. We have to say this is angle A. Perfect. Now the next angle. What should be the next angle? Friends, look at the quadrilateral ALOMA. Very simple case. Obviously बात है. But this line is the normal. This line is normal, and this is the surface. This line is normal, and this is the surface. Means this total angle will be 90 degree. This total angle will be 90 degree. This angle is O, and again this line is the normal, and this is the surface. So this angle will again be 90 degree. So in total, we are having 4 different angles. The first angle is A, then 90 degree, then O, then 90 degree, like this. I repeat, first is angle A, then 90 degree, then angle O, and then again 90 degree. So I am just going to use this concept, and I have to say the first angle is A, then with 90 degree, फिर what? Angle O, फिर what? 90 degree. तो first angle, second 90, फिर angle O, फिर 90, and by angle sum property this total result should be what? 360 degree. Very simple case. So what should be the next point? A plus angle O is now 360 degree minus what? 180 degree. So friends, answer is going to be like this. Angle A plus O is now 180 degree. 180 degree. This point is clear. What to do after this? Now the triangle. We have to consider the triangle LOM. You have heard right? The triangle is LOM. Let's write down. Here also 3 angles are there. How many angles? 3. The first angle is R1, second angle is R2, and the next angle is O. R1, R2, O. The sum of 3 angles of the triangle is again equal to 180 degree. So means we have to say R1 plus R2 plus angle O should be equal to what? 180 degree. So let's write down. What I have to say? In triangle. What is the name of the triangle? The triangle was LOM. What is the name of the triangle? LOM. Look at the figure, friends. The triangle is where? LOM. LOM. So we have to say R1 plus R2 plus angle O should be what? 180 degree. Let this be equation number 2 and let this be equation number 3. So obviously from equation 2 and 3, friends, from equation 2 and 3, if I compare, so we have the result what? A plus angle O should be equal to what? R1 plus R2 plus angle O. So means this result gets cancelled with like this. So what is the final answer? The first result, final answer which we are having is nothing but R1 plus R2 and should be equal to what? Prism angle A. I hope it's clear to you. So actually we had the target of deriving 2 results. We need to find out R1 plus R2 and then we have to go for I1 plus I2. But the first derivation which we have completed is for what? R1 plus R2. So friends, look at the result. We have derived the concept of R1 plus R2 and this is nothing but equal to what? Prism angle capital A. So now the next target which we have to cover is what? So let's write down. to find I1 plus I2. We have to derive I1 plus I2. Right friends, the next target which we are going to start is the derivation of I1 plus I2. Now friends, our target is for the derivation of I1 plus I2. So what should be the logic? So let us consider 2 points. The first point is L and the next point is M. The first point is L and the next point is M. So the first point L. So we have to say at point L. What is the first point? The first point is L. And at point L we have to do what? We have to use Snell's law. Which law we have to use? This is nothing but Snell's law. So friends, first of all look at the point L. Where is the point L? This is the point L. The first angle is I1, this angle is I1 and refraction is R1. So by Snell's law we have to say final medium is what? 2. And initial medium is what? 1. So 2 is called as what? Glass. 2 is called as glass. Let the refractive index of glass be taken as N. The symbol for the refractive index of glass is taken as N, while for air the refractive index is taken as 1. So I mean to say, for glass we have to consider refractive index as N, and for air we have to consider the refractive index as 1. So means friends, we have to say N1 is equal to 1 and N2 is equal to N. You have heard right? N2 is equal to N for glass. For glass we have to say N2 is equal to N. But for air we have to consider the refractive index as N1 is equal to 1. If this concept is clear to you, so let's use Snell's law at the point L. So N2 divided by N1 is equal to sine I1 divided by sine of R1. Right friends? And this is written as I1 upon R1. Very important step. All of you must be having some confusion. Why I am going to write I1 upon R1 in place of sine I1 and sine R1? Friends, there is a concept. When angle is very small, then we say what? Sine theta becomes nearly equal to what? Theta. Sine theta becomes nearly equal to theta. Using the same logic, we can say sine I1 is now nearly equal to I1 and what? Sine R1. This is nearly equal to R1. This concept is clear to you? Some students might have doubt. Bhai, what is this? Somewhere we are considering I1, somewhere we are having sine I1. So how to get it? Confusion might arise. So for this I am going to consider some example which says that if you have angle 0 degree, sine 0, then its value is what? 0. If the angle is 0 degree, the value is also what? 0. Means there is no impact of the function called as sine on the value of the function. The function is again equal to value, the equal to angle. Angle is 0, value is 0. So for the smaller angles, there is no role of the function. So keeping this in mind, we have to consider sine I1 as I1 and sine R1 as R1. If this point is clear to you, so I am again going to repeat N2 by N1 is nearly equal to I1 upon R1. Right. I hope this point is clear to you. If this value is clear, so nothing, no problem is there. N2 is what? N for what? Just you have understood the concept. This is valid for glass and N1 is equal to 1. This is defined for what? For the medium called as air. If this point is going to you, then nothing to worry. What should we do? Just the next step. What should be the next step? N upon 1 is nearly equal to I1 divided by R1. N upon 1 is nearly equal to I1 divided by R1. Now the cross multiply. So after cross multiply, we get the result. What is the result which we are going to have? We have I1 is equal to n times of R1. You have heard right. I1 is equal to n times of R1. So friends, let me circle it out, bracket it out like this, so that this result will be highlighted result, very important result which we have derived till now. Now the next point arises, will this theory work with the same point M also? With the next point, where is the next point? Wait, this is the next point. Will the same result going to work for the point M also? I doubt, because here the first angle is I1, next is R1, but here the first angle is R2 and next will be I2. So friends, we have to move step by step. There should be no hurry, because in pressure you do mistakes. So just ease out, just relax, and step by step go for the derivation. So what is the next point? The next point which we are going to consider is the point M. So last point was L. So this is M. We are going to consider point M. What to do with this? Nothing to do. Very simple case. By for M, again use Snell's law. We are going to write down by which law? By Snell's law. So what is Snell's law? By look at the figure. Where is the figure? This is the figure. This side. Now the light is going from glass to air. I think the final medium will be what? By final medium will be air. N1 equal to 1. And initial medium is the glass. N2 is equal to N. So nothing to worry about this. This is final medium and this is initial medium. For which point? The point is called as capital M. So what are you waiting for? Just go for the Snell's law and let's have it in our copy, in our notebook. Where is the Snell's law? This is the Snell's law and the point is capital M. Final medium is air, so N1 upon N2. This point is clear. So what should be the angle? Sine R2. Remember friends, the first angle was R2 and the final angle was I2. If you doubt, so I again go back to the figure and just see the figure. The first angle was R2 and the final angle was I2. First is R2, final is I2. Hence in the Snell's law we have to write down R2 divided by I2, and using the same concept by the small angle we have to say this is R2 divided by I2. Now N1 upon N2 is nearly equal to what? R2 divided by I2. Now friends, you remember the value very well now. N1 is equal to what? N2 is equal to N. And what should be this? By this is R2 divided by I2. Again go for cross multiply. So let me write down in words. After cross multiply. When I cross multiply the result, the question arises, what should be the final answer? My final answer is nothing, very simple, very easy. So we have derived the result as this is I2 is equal to N times of R2. I2 is equal to N times of R2. Very well friends, right? Nice result. By what is the case? The first we have derivation I1 is equal to NR1 and the next derivation is I2 is equal to NR2. So finally we have to what? I1 plus I2. We have to do I1 plus I2. So after copying the result, this is NR1 and this is what? NR2. If we take N as common, the result will be R1 plus R2. And dear friends, you very well know just the last derivation. R1 plus R2 was equal to what? A, prism angle A. So friends, after R1 plus R2, we have derived I1 plus I2. Look here. This point is clear. Now go back. Where is R1 plus R2? This result is R1 plus R2. You have the derivation. And this result is I1 plus I2. So what are you waiting for? Look at the main result. What was the first result which we had started in the beginning? By this was the formula. Deviation is equal to I1 plus I2 minus R1 plus R2. So now you have the result. You have the result for R1 plus R2, that is equal to the prism angle A. And also we have derived the result for I1 plus I2, that is nothing but NA. So next we are going for the final step of the derivation, or last step of the derivation, that is the prism angle, and that will be the final step, last step of our derivation. After this it will be the complete concept of angle of deviation. Okay friends, well friends, till now, the final result, which will be the key step or the main step for our derivation, will be like this: minus of R1 plus R2. Right. So we have the derivation as this. This result is written as NA. Right, friends? Minus what? This should be written as A. Now some students might have confusion कि A minus A should be cancelled. By this is the blunder mistake. You cannot cancel A with A like this, because here the number n is also there. If n is attached with capital A, then how can you cancel these two values? So no blunder mistake, nothing. We have to take A as common, and the end result will be del is equal to n minus 1 times of A. Del is equal to n minus 1 times of A. So friends, this was the topic which we had to cover, and I had mentioned in the beginning that we are going to have the derivation for prism angle del that depends on, not prism angle, it is not the prism angle, it is the angle of deviation, and this is the prism angle, and this thing is called as the refractive index. Let me write down, by confusion might be there. This is angle of deviation. This is angle of deviation. And this thing is what? This is called as prism angle capital A. This is prism angle capital A. The last but not the least, this is refractive index. This is called as refractive index. Right. I hope the concept is clear to you. And the last, bilkul last, the end concept of the topic with the heading minimum angle of deviation. This is the note, or this is the last concept, minimum angle of deviation. So friends, the question arises, after deviation, how we are going to have minimum angle of deviation? What are the conditions for minimum angle of deviation? But nothing to worry, very easy case. You just have to remember two things. For minimum deviation, let me write down, for minimum deviation, I hope it is visible to you. For minimum deviation, the concept is like this: R1 should be equal to R2, and that is equal to R. Remember the case, R1 should be equal to R2, should be equal to R. By if this is the point, where is the problem? Nothing is there. We have the result, R1 plus R2 was equal to capital A. Very well know, R1 plus R2 is capital A. Just replace the value. This is R and this is also R. So finally this is A. So friends, this is twice of R equal to capital A. What about the end result? What about the end result? What is the result which you are going to have? You may say, sir, R is nothing but equal to A by 2. R is nothing but equal to A by 2. I hope this point is clear to you and you are able to get this concept, right? Now the last step. What is the last step? For the last step, we have the case del is equal to I1 plus I2 minus R1 plus R2. Right, friends? So same case for minimum deviation. What I am saying, for minimum deviation, what is the condition? By condition is nothing but I1 should be equal to I2 should be equal to I. I1, I2 equal to I. And del is equal to del M. Del is equal to del M. If that is the point, so apply the result. Let's have the formula. Let's use the result. So concept is like this. Del minima is now written as I plus I. Right, friends? Minus capital A. So finally we have to say del minima is nothing but twice of the incidence angle minus the prism angle capital A. If on simplification we are going to write it down like this: del M plus capital A divided by 2. You have the right result. This is called as incidence angle. This is called as incidence angle, and this is called as the refraction angle. So you are going to have two different results. One is for the incidence angle, and this is written as prism angle plus minimum deviation divided by 2, and this is written as prism angle divided by 2. So Friends, after this what we have to do, nothing but the last step, go for the Snell's law. Just write the Snell's law. So what does the Snell's law says? It says that n is equal to sine I divided by sine r. N is equal to sine I divided by sine r. If this point is clear, so now just go for the incidence angle and the refraction angle. Just replace the value of incidence angle and refraction angle. Where, in which formula? Friends, this is the formula where you are going to replace the value of incidence angle and refraction angle. Hence, the complete result will be like this: A plus del minima by 2. And what about this? Friends, this is nothing but A by 2. A by 2. So end result will be like this. U. This is the complete formula. Refractive index of the glass is equal to sine of A plus del minima, minimum deviation by 2, and this is sine of A by 2, prism angle by 2. So some students might have the confusion that we may cancel 2 with 2, but this will be the blunder mistake. You are not allowed to do this calculation. 2 will not be cancelled with 2. You just have to keep the value of 2 because there is a log called as sine function in the numerator and in the denominator also. There is no liberty like this. You have to remove the values of 2 in this manner. You will get 0 in the exam. So this is the final result. This is the complete result. Just keep in mind this. You have to learn this formula only. Right, friends? So this was the result which we had derived: refractive index and the sine of incidence angle and sine of the refraction angle. Right? Now, if this point is clear to you, so I am just going to finish the lecture with a very nice question which have been asked in the board exam, previous year question. Very easy, but first of all you should try. After that you can say it is easy or not. So let me write down the question. If there is minimum deviation, right friends, if there is minimum deviation, and one more thing, if there is minimum deviation and the deviation angle is equal to incidence angle I, deviation angle is equal to this is not I, this is equal to prism angle. I am sorry, let me correct it. This is equal to the prism angle capital A. Right friends, this point is clear. And one more thing else is being given in the question, that is refractive index of the glass of prism material is written as √3. You have heard right, this is being mentioned as √3. So now the final question, what is the question being asked in the exam? Find the prism angle. You have heard right, find the prism angle capital A. Find the prism angle capital A. Okay friends, if the video is clear to you, then you have the full confidence in this question, and I expect or I guarantee that you are going to solve this numerical, right? To solve the numerical and show me the answer or write the answer in the section called as what is the section called as, friends? Comment box. You very well know this is the comment box which you will reply me, and please reply your answer because this will boost your confidence for the coming board exam, and as your confidence grows you will get more and more marks in the exam, right? Hope for the best. Try the question, and also please share and subscribe the channel. Share and subscribe the channel. Why should you subscribe? Because there is a motto for me: your subscription is my motivation. More and more subscription, more and more number of subscription is there for me, then that will motivate me to bring more and more good videos like this on physics topic. Okay friends, so till the next video, there is a very nice bye. So let me write down bye.